All right, last lesson, we talked about the fact that you can write thermochemical equations for more than just chemical reactions. You can do it for changes in state or dissolving. So I want to talk a little more in detail. This is actually going to take a couple of pieces from the last couple of lessons and talk about what happens to heat during phase changes. All right, so we saw this before. During a phase change, so, say that this is water. Right? If we start out with really, really cold water and we heat it up to the point where we start melting it, during the actual melting process, there actually isn't a change in temperature. All right? It'll actually, for a period of time, it'll plateau like this, where the temperature will stay at 0 degrees Celsius until the water has actually gone from solid to liquid. All right? And that's where these heat of fusion and heat of vaporization stuff comes in. So let's talk about how we use those. All right? Every substance has a specific heat of fusion and heat of vaporization. All right? If you need to do a calculation, you can calculate the heat, the Q, the amount of energy that is needed to evaporate, freeze, melt a substance by taking the mass of that substance and multiplying it by these constants, either the heat of vaporization if you're dealing with a gas-liquid change, or the heat of fusion with a solid-liquid change. So, for example, the heat of fusion for water is 334 joules per gram. All right? We want to calculate the heat necessary to melt 500 grams of water. The trick to these problems is you have to assign the sign, the positive or negative, to our heat of fusion or heat of vaporization. So you've got to sit there and think about it. All right, if I am melting water, that means the water is going to be going from solid to liquid. Liquid molecules move around more, which means they have more energy. Okay, this needs to be a positive value because this is going to be an endothermic process. So all you do is take your mass, the 500 grams, and in this case, you're going to multiply it by positive 334. Which ends up being 167,000 joules, or you could say 167 kilojoules. I divided that by 1,000 to go from joules to kilojoules. So how about, what if we did the opposite? We took that 500 grams of liquid water and we refroze it. What would our Q value be in this change? All right, so same mass, except this time we need to remove the energy from the water molecule so it'll go into the solid state. So our heat of fusion is going to be negative. So exact same answer, 167, except there's going to be a big fat negative sign out front. All right. So you need to, hopefully you can just kind of think your way through this, but if it helps, melting and evaporating, those are positive. Freezing and condensing, you're going to have negative values for your heat of fusion, which is these guys, or your heat of vaporization, which is those guys. All right? So, this is the worst. And honestly, you probably won't see one like this much, but this is the challenge to putting all of this together. All right? So say we are going to take water from negative 12 degrees Celsius to 150 degrees Celsius. All right, we've got a bunch of things going here. We are going to have some temperature changes, so we are going to have to calculate Q using the mass times specific heat times delta T. But then there's also going to be, when we hit 0 degrees Celsius, we're going to go from frozen to liquid. We're going to melt, all right? So we're going to have melting going on here. And we're going to have evaporating going on here. All right, one thing I forgot to write down is delta HV of water is 2260 joules per gram, and delta HF of water, which we actually know from the last one, is 334 joules per gram. All right, ultimately, I want you to try and see if you can get this on your own, or at least try the different parts. But there's gonna be 5 steps to this. All right, you're gonna use your Q equals MC delta T for negative 12 to 0. And then you're gonna use Q equals M delta HF for melting. Then you're gonna use Q equals MC delta T for 0 to 100. And then you're going to use Q equals M delta HV for boiling or evaporating. And then one last Q equals MC delta T for 100 to 150. All right, keep in mind there's different C values for the state that water is in. So, pause, see if you can figure this stuff out on your own. I am going to pause as well, do the calculation, and then I'll start it up so that you can see what the final answer would be. Okay, here is my calculation for the 5 separate parts. All right, you can see the work that I did, the different values that I got. The last thing I would do now is take these numbers and add them together to get the total change in enthalpy. So that's going to be 4920 plus 66800 plus 83600 plus 452,000 plus 2800. Let me add those together. You can see that the state changes tend to have much larger numbers than the temperature changes. So as long as I didn't make any stupid math errors, which sometimes happens when I type things into a calculator, I got 628,120 joules, or 628.12 kilojoules. That sounds about right. Hopefully you were able to get that too. If you didn't or you have questions, you can let me know.